very much. Let me go here. All right, welcome. So my name is JB Rainsberger, or JBrains. That's kind of how I'm known, and those are the ways that you can find me these days. JBrains is also my handle on Twitter. I have not left Twitter yet, but I admit I'm not there as much as I used to be. And if at any point you'd like to ask a question after today, and I have disappeared and I'm not in the Slack workspace anymore, you can always visit ask.jbrains.ca, and that's where you can ask me questions anytime. I'll make you the same offer that I make to everyone. If you are willing to wait an indefinite period of time for the answer, then that service is free. But if you need a better service level agreement, if you need answers within a certain period of time, then we can talk about how much that costs, and I promise it's not as expensive as you think it is. And so now I'm realizing that I might be on the wrong corner of the screen, but we'll see how bad it goes. I might have to duck out of the way of some of the words here. So what I'd like to talk about today is this common pattern that I see among programmers who have attempted to incorporate refactoring into their overall work. And one of the things that they found out, I'm now realizing I'm actually in the way of the, yeah, there we go. Let's move a little bit that way. There we go. Now at least you can see the icons. I'm sorry about this. The people who try to incorporate refactoring into their daily work find a couple of common problems. One of them has to do with, I can't convince the people around me to do refactoring with me, which is a different problem. The other one is this one, that I have this vague feeling that refactoring would help me in my day-to-day work as a programmer, but I never really feel comfortable using it as a primary design technique. I might have learned a little bit about it, I might understand a little bit about it, but each time that I try to really guide a design to evolve, I never feel comfortable really doing it. And what that leaves me is in this constant loop of, I'll try it again next time, and then next time comes and I still don't feel comfortable because I haven't practiced. So I'll try it again next time, and then next time never comes. And so what I am encouraging you to do, partly in this talk, is to practice deliberately. One of the good things that has come out of this global pandemic, one of the few really good things that's come out of it, is that a lot of people have had a chance to work from home for an extended period of time for the first time in their careers. And they don't have to worry as much about people watching them while they're doing work. There isn't quite the same sense of urgency that there is when you're in an office and everyone can see what you're doing and you're attending status meetings every day and so on. It can be very easy to feel like everybody's watching me. I don't have the opportunity to try to practice. And that is the primary reason why you get stuck in this loop. And so if you can find a way to practice deliberately, then what that will allow you to do is to focus on refactoring as a technique, focus on understanding what it means when you try to guide designs to evolve. And really, this last point is the key for me. What you're doing is not indulging yourself in doing fun work. What you're doing is increasing your personal capacity to do work for other people, to evolve designs, to help other people, to save time, to increase energy. These are all things that will allow you to give more to other people. Now, if you want to save all that for yourself, feel free, but that's really what's going on here. If you're worried that other people will think that you're just slacking off or not doing real work, far from it. You are investing in increasing your own capacity to do work, which will allow you to save some of that capacity for yourself, to rest, to do better work. But you can also give that to other people in the forms of things like pairing and so on. And so why don't you refactor more? I'm curious, what kinds of reasons do you have why you don't refactor as much as you think you should? And in fact, yeah, while I'm waiting for a couple of those answers to come up, I just want to see whether by chance I can. Yeah, that's what I want. So while that's happening, I'm going to take advantage of the opportunity to do a little refactoring. And I believe I want to be here. All right, see, we can refactor even in a presentation. So I see a few problems here, like pressure to provide new value instead, or it requires too much testing, or we don't have enough tests, or if I refactor, I'm going to hurt other teams. These are all very common reasons why we might not be able to refactor more. And in fact, providing new value instead is the primary area of conflict that I noticed. And I wrote about this many years ago. You can find an article called The Eternal Struggle Between the Business and Programmers. One of my central theses, one of my central ideas is that when you refactor, you are increasing your capacity to deliver features sooner, and that the product manager or project manager or technical lead or whoever it is who is yelling at you to ship features, more and more features, doesn't realize that by getting out of your way and letting you do the refactoring that you know you should do, you're actually giving them what they want. And so that's part of what we want to talk about here. So thanks very much for all these ideas. We'll come back to that. Here is a pattern that I see all the time. When I talk with programmers and I ask them the question, why do you think you haven't got any faster? You've been practicing test-driven development for 6 months or a year. Things don't seem to be getting faster or easier. Why do you think that's happening? And this is what they tell me an awful lot. They said, well, I don't know how to refactor this code. Like, I can picture in my head how I would design it differently now, but I don't know how to go from here to there in a bunch of refactoring steps. Those incremental steps that Martin Fowler wrote about 25 years ago, I can't see the path. And because I can't see the path, I don't do it. Now, I could try to invent the path as I go. I have some knowledge of refactoring. I know how to take 2 or 3 steps, but then I sort of get lost. And that means that I would spend too much time trying to figure out really where to go. So if I try to refactor this code, it'll just go too slow. It'll go too slowly. And because it goes too slowly, I really can't afford to try it. I feel too much pressure to deliver features. I feel too much pressure from my teammates, from my technical leads, everyone. And that means I can't afford to try refactoring this code. And here's where things start to get dark. And it's the path from I can't afford to try to refactor this code to I will never trust myself to refactor any code. And this is what I see happening over and over again. The programmer convinces themselves that they will never be fast enough to refactor in an industrial strength pressure situation for money. Now that starts to feel pretty dark. This is now we're starting to move into some pretty serious learned helplessness territory. It gets worse because we don't just say, I can't afford to try to refactor this code. Once you experience that 10 times, it becomes, I will never have the opportunity to refactor code. I will never trust myself to refactor code. It will always be a dream. It will always be something that I wish I could do, but I can't do. And that means that I am forced to live with the consequences of design decisions that were made last week, last month, last year, by other people, or by me when I was under pressure. Those design decisions are a prison from which I cannot escape. I will never be able to do good work here. Maybe I have to quit. Maybe I have to quit this team. Maybe I have to quit this department. Maybe I have to quit this company. Maybe I'm just not a programmer. Maybe this job isn't for me. Maybe I should go do something else. And you might think that I'm being overly dramatic, but I'm telling you, this is what happens. And some of you out there might have felt this. And part of what I want to do today is to help you get out of this feeling of learned helplessness, realize that there is, in fact, a path forward. Now, what's missing here is what psychologists call chunking. And chunking really just refers to, whoops, let's try it again. That's interesting. Something is broken here. There we go. I have to use different keys now. As you practice doing something, you chunk. What chunking means is that things which used to feel like a bunch of separate independent steps where you have to pay attention to each step individually, When you chunk, that begins to feel like one step in your mind. So I used to have to worry about which keystrokes do I have to press to move this method from this class to that class, or to extract these 5 lines of code into a method. And now if I want this code to be in a method on that class, I have to extract it to a method and then move it over there. And that felt like 2 or 3 or 4 steps, depending on your tools. But eventually, as you do it often enough, it starts to feel like just one move. I think of it as one thing, and when I want to do that one thing, my fingers know how to do it. When you chunk, what happens is that the front of your mind no longer has to pay attention to the detailed steps. They happen in the back of your mind, which is much faster and burns much less energy. And you end up performing those steps. It's like your fingers know how to do it before your brain even gets involved. And you just immediately reach for the keystrokes. You just immediately reach for this menu item, followed by that menu item, followed by that menu item. And that's what is missing for many programmers. They don't give themselves an opportunity to let chunking happen. Now, chunking is something that happens at every level. Everything's a tree. That's what makes computer science beautiful, right? If you have a tree, then a strategy that works at one part of the tree works for every part of the tree. And there are various levels. There are nano steps, like which keystroke do I press in order to extract these lines of code into a method? There are micro steps, such as, okay, I need to replace inheritance with delegation. There are moves. If I do these micro steps in this sequence, it adds up to this big restructuring. And then there are strategies, things like, oh, let me introduce a whole value, and then it will attract code from around the code base. At every level, chunking happens, so that today I have to focus on nano steps, but in 3 months, I have mastered those nano steps and I don't even think about them anymore. I think about the micro steps that they add up to. And the same thing moving from micro steps to moves and from moves to strategies. Repetition is the key. It starts with repetition. Repetition leads to ease. Ease leads to chunking. If you repeat something often enough, then you can do it without conscious thought. My fingers just know how to move around in Cocoon, which is Vim if it was invented in the 21st century. Or they know which keystrokes to use in IntelliJ IDEA. I have a level of autonomic behavior in those tools that I know that I don't have if I have to work in Ruby in a plain text editor. That's why the Pragmatic Programmer book had an entire section called Learn One Editor and Learn It Well. They wanted you to chunk. When you repeat something, you can do it easily with less conscious effort. It requires less energy. You see one step instead of 10 tiny steps. And this doesn't just make you go faster. This is the key point. Going faster is nice, but the real important thing that happens is that it frees your mind to think at a higher level of abstraction. If you're focused on how to perform the refactorings, it will be harder for you to think about if this refactoring is a good idea right now. How much will this help me? And this is where a lot of programmers get stuck. They never reach the point where the refactorings feel easy. And so they are constantly worried that they're making a bad choice because the front of their mind is wasting energy thinking about extract this code, move it there, extract this code, move it there. All right, this keystroke, that keystroke, that keystroke. When those steps become easy, then you can start thinking about, okay, well, let me just start trying to move in this direction and see if it works. Oh, no, that was crappy. Let me back up and try a different way. When you chunk, you don't only go faster, but you think about bigger things. And making the transition from micro steps to moves is what allows you to feel confident refactoring. That allows you to say with confidence, this refactoring is probably going to be a good idea right now. And long term, what you want to do is to reach the point where you say, I'm not worried about whether this refactoring is a good idea right now, because I can try it for 10 minutes. And if it's terrible, I just undo and start again. And all of that starts with repetition. When you repeat the micro steps and the nano steps often enough, then you stop thinking about them entirely and your mind can think about strategy. Should I do it? And you just repeat these steps until wisdom comes. And then you build that wisdom up as you go for the rest of your career. So think about this for a moment. I don't know if people will really have time to reply, but Think about things that you do now without thinking, that at some point in your life in the past required conscious thought. It was actually difficult. Walking is a perfect example. Breathing, eating, driving. How many times I don't drive, but I've heard stories that people sometimes will drive home from a location that they go to frequently, like the office or a store, and they have no conscious memory of driving. Typing is another perfect example. We all know the saying that typing is not the bottleneck. It's true, but if you type 100 words a minute, lots of good things can happen. Following a recipe in cooking. If you do the same recipe every week, then after a while, you don't have to think about it. I don't have to think about when do I grab this ingredient. You can even optimize the sequence in which you do things. Not thinking about my ex? Well, good luck with that. So all of these are things that you learned how to do really, really well with very little conscious effort. How? By doing it again and again and again and again. And again, this is one of the things that programmers get in trouble with. They don't let themselves go through the repetition, which leads to ease, which leads to chunking. Now that I've said repetition leads to ease, leads to chunking, if somebody asks you what the hell you're doing, you can say, well, I'm just chunking. I'm building better memory. I'm building a richer mental model of what I'm supposed to be doing here so that it will be easier. Instead of something like, oh, I'm practicing, which is good, but sounds like a waste of time. Chunking means engaging system one. So if you know this book, then you know the metaphors of system one and system two. What you're doing is you're moving tasks from here, system two, to here, system one. And back here, everything is faster. It's always on. It's always paying attention. And it's what allows you to do things without thinking. And again, when we move work from the front of the mind to the back of the mind, we don't just go faster. It doesn't just get easier, but now I have more space in here to think about bigger things. Is this a good idea? Should I do it this way or that way? Should I do it now or next week? Is there another task I should be thinking of instead? And so this is the magic of chunking. And the beautiful thing about chunking is that chunking happens whether you like it or not. You don't have to do anything. All you have to do is repeat something. If you repeat something often enough, chunking happens, is happening all the time. It's happening now. So now what does this really look like? Here's a bunch of examples of things that you do that I've sort of loosely categorized into nanosteps, microsteps, moves, and strategies. And when you do chunking, it's not very orderly. There are some nanosteps that you still have to pay very close attention to, and then some moves that you can think about easily. So it's not like you master all the nanosteps, then all the microsteps, then all the moves. You move around. And there might be some nanosteps that you have to relearn when you go to a new environment. When I was switching from Vim to Cocoon, the big difference between those two editors is that Cocoon is very object-verb based. You select first, the commands start with the object and then the verb. So it's 2 words copy instead of in Vim where it's copy word or copy paragraph or copy line. And so this idea of switching to object then verb took me several weeks to get used to, but now I can do it quickly. And when I have to go back to Vim, I have to remind myself, oh no, this is verb then object. So nanosteps are not something that you master once and they're yours for life, because when you move to a different environment, the nanosteps are different. But the nice thing is that once you master the nanosteps, if you've mastered the microsteps in another context, those things tend not to change. Strategies are more stable. Moves are more stable. So once you master a strategy, you can use it in any environment, for any set of tools, in any situation. And remember, one of the key things about chunking is that you don't just go faster. It doesn't just get easier. I can think more about more important, more valuable decisions. Like, how am I going to design this? How much design will I do up front, and how much will I do as evolutionary design? Will I write tests first or not? These are questions that are very difficult for me to consider when I still have to remember, oh, extract these. If I extract this block of code and it takes a customer as an argument, then I can safely move that automatically onto the customer class. This is why chunking is so important. And it pains me to watch programmers who don't let themselves do it. So now here is an example. I'll talk through an example of a move. And the move is replacing a single item parameter with a collection parameter. So I have a function that used to take a single number, and now it needs to take an array of numbers or a list of numbers. This is one of the classic refactorings that you'll find in Martin Fowler's book. So here's one example of how to do the micro steps. So the first thing we do is we go to all the code which calls our function f. And where it passes 12, we now pass a second argument, which is the list containing only 12. It's the same argument in two different forms. And once I've changed all the invokers to do this, then I go inside the body of the function f. And everywhere that I'm reading from the variable x, I instead read from x is at 0 or x is dot first, however you do it in your language. And then I reach the point where the function f is no longer talking to x, which means that x can now be removed. I can now go back to the invokers, and I can change them all to pass only the list of 12 and not 12. And if you're working, say, in JavaScript, maybe you have to do this in two stages. The first stage is to change all the first arguments to undefined, make sure that the tests are still passing, and then do a search and replace. And then I go back inside the body of f, and I can say, well, the good news is f is talking to the list of x's. The bad news is it always assumes that there's only one of them. So now I need to do the hard part. This is the part that requires the most conscious attention because I could get it wrong. I could fail the tests. Let me now go and decide each time I talk to x's at 0, let me replace that with iterating over the list of x's. Is it a for each loop? Is it a fold? Is it a map? Is it a whatever? So this is one example of the sequence of microsteps that you can learn to do in order to perform a move. And so you'll start by printing out this page, putting it beside your computer, trying very hard to do all the individual steps, to do step 1 safely before you try step 2, do step 2 safely before you try step 3, and to try to do the nano steps the same way every time. Once you master the nano steps, then you can do the micro steps without thinking about how to do them. Then you just have to remember this one, then this one, then this one, then this one. Finish all of step 1, then all of step 2, then all of step 3, then all of step 4. And then eventually that gets easy. And then you don't have to think about that anymore. Then you'll look at this and go, oh, this is just the Kent Beck approach. Add the new thing, migrate the clients, remove the old thing. Step 1 is add the new thing. Step 2 is migrate the clients. Step 3 is remove the old thing. And then step 4 is actually add the feature. So this is, again, the Kent Beck approach of steps 1 through 3 are make the change easy. And then step 4 is make the easy change. So if you have tried to follow these guidelines in the past and they sound good, but you think, I have no idea how to do that. If you allow yourself to focus on the nano steps and master them, and then on the micro steps and master them, then gradually you will see the strategies involved here. Why this works well. Why do we bother doing it this way instead of just changing the signature of the method and then letting the compiler guide us to make all the changes? I mean, you could do that, but this way we know that we can keep the tests passing all the time. It's safer. So repetition leads to ease, leads to chunking. If we perform the nano steps, or in this case, if we perform the micro steps in the same sequence every time, and then we perform each micro step as the same sequence of nano steps every time, and then perform each nano step the same way every time, that repetition is what will lead to ease, what will lead to chunking. And so I actually encourage you to try this as a drill. Set a timer for 30 minutes, find a random function in your code, and perform these steps. And all you're trying to do is to do the same steps in the same sequence, the same way every single time. And when I ask programmers to do this, most of them think it's ridiculous. But at the end of 30 minutes, when I ask them how it feels, every single one so far has said, you know what? At the end, it felt easier than at the beginning. Good. Try that once a week for a while. And then if you're really adventurous, try it once a day. Now, here's another alternate set of micro steps that achieves the same thing. I won't walk you through it. You can read it if you want. But what's important to understand here is that there might be different kinds of micro steps that you learn that might be easier in different environments. These micro steps might be easier in Java, where you have more automated refactorings, such as introduce parameter. Whereas the previous set of instructions were better for Ruby or JavaScript, where you're doing more of the nano steps by hand, by just editing text. The tools that you have will affect which micro steps you learn. And so I perform the refactorings in a different sequence in JavaScript than I do in Java, because of the tools that are available to me. And as IntelliJ IDEA becomes more advanced, that gap is slowly narrowing. But at some point, I'm going to want to do some pure script in Atom or in Cocoon, and I'm going to have to learn those micro steps again. I'll have to learn the nano steps again. But at least if the micro steps are comfortable, then learning the nano steps is easy. It's just learning a new implementation of the same interface. By the way, there's no rush. Start anywhere. Learn any nano step, learn any micro step, learn any move, any strategy. Who cares? Do what makes you happy. Follow your energy. But pick one way to do it. Really force yourself to do it the same way every single time. Repetition leads to ease, leads to chunking. And step 3 is the most beautiful part, because eventually it gets boring. And that's when magic is happening. When it gets boring, you're mastering it. And then you can try something else. Try doing it a different way. Try doing something else. I want as much as possible for these steps to feel the good kind of boring. Now it gets better. Chunking leads to confidence, leads to courage. But before we go there, since someone has raised their hand, if there is an immediate question, let's ask it. I might answer it at the end. Can we do that, or should I just keep going?
Yeah, I think you can just keep going. And
okay,
question.
We'll gather those questions at the end. So I hope it's not the kind of question where you're lost. I hope it will be okay. So chunking is good, but chunking is not the end. Chunking leads to confidence, and confidence leads to courage. This goes back to how I started. When you chunk, you feel less resistance to refactor. You volunteer to do it more. You feel less pressure. You feel less risk. You have more capacity to recover from mistakes. Mistakes aren't mistakes anymore. They're just experiments. If you have less resistance to refactor, then you will have more impulse to refactor. You will try to do it more. You will choose to do it more. You'll do it in more difficult situations. You'll do it when success seems less certain. Repetition leads to ease, leads to chunking, and now you have chunking at higher levels. Then the real magic happens. You feel hope. This will actually help you. And when you feel hope, you see new opportunities and you will actually do it. You won't just sit there like the guy at the beginning saying, I want to refactor, but I'm never going to be fast enough and I can never afford to do it. Repetition leads to ease, leads to chunking. Chunking leads to confidence, leads to courage. So you can start practicing now. But if I just let you go run into the street and practice, you'll be banging your head against the wall and getting frustrated. So let me give you some ideas. Try spending 30 minutes at the end of every task. So if your programming tasks are between, say, 1/2 day and 2 or 3 days, which is fairly typical these days, then you can always add 30 minutes and nobody will care. Nobody will yell at you for taking 30 minutes more. So at the end of a task, set a timer for 30 minutes. Now it's wonderful. Almost all of us have timers in our pockets. Set a timer for 30 minutes at the end of every task and try to practice some refactoring. Pick any refactoring and try it. It doesn't matter which one. Follow your energy. You could try a refactoring which seems interesting because you tried it last week and you failed and you want to try it again. You could pick a refactoring because you think it will be helpful for this code. And it's okay if you only get 10% of the way today. None of that matters. All that matters is that you invest time in practicing. And if you don't feel confident investing a lot of time, then you start by investing a little bit of time. 30 minutes at the end of every task, 30 minutes once per week. At the end of 30 minutes, you don't have to keep your work. You can throw it away because what matters is what you learned, not what you did. If you find out that you actually completed a refactoring that makes the code better and your teammates will be happy, then ship it. Great. All that matters is that you keep trying. So this reminds me of when I first started meditating. Almost everybody who does meditation at some point starts to wonder, am I doing it right? And then you'll get some people who will try to helpfully say, well, there's no such thing as doing it right. What's wrong with you? No, that's not a helpful answer. I didn't come here for a riddle. I came here for an answer. Doing meditation correctly is simple. All you have to do is start again. Did you miss a day? That's okay. Start again. Did your mind wander partway through? That's okay. Start again. Did you forget what you were supposed to be focusing on? That's okay. Start again. Did you start planning the rest of your day? That's okay. Start again. And I want this to be like that. It's okay. Start again. As long as you keep trying, you are allowing repetition to lead to ease, to lead to chunking, to lead to confidence, to lead to courage. That's all that matters. So now here's a few tips. Practice is not performance. When you are practicing, I want you to put yourself in the mindset of a person who is practicing. I'm not going to ship this. I might not even improve the code. I'm just practicing the steps so that when I do them under pressure, I do them more accurately, more safely, more quickly, more easily. And so that's one good reason to hire someone like me, because I can create an environment in which your managers and your vice presidents agree that it's socially acceptable for us to not ship real stuff. We can just practice. That's what the trainer is here for. But you don't need me to do that. You can do that on your own. 30 minutes at the end of every task. And by the way, if 30 minutes is okay, if nobody is yelling at you to go faster, then you could try an hour and wait for angry emails, wait for an invitation to a special one-on-one meeting with your manager who says, hey, I've noticed that you're slowing down and not doing real work. Okay. As long as nobody is giving you a problem, then you can try doubling your practice time until somebody complains. And now you know the limit. Now you know how much you can afford to invest in practice. And if you do it for a few months, then you'll start to notice that your practice is paying for itself. And during practice time, you're not performing. You don't have to improve the code. You don't have to ship it quickly. All that matters is that you allow yourself to do the repetition that leads to ease, that leads to chunking, that leads to confidence, that leads to courage. Some of you out there will say, I don't have time to refactor. That's how we started here, right? The problem isn't that you don't have time. The problem is that you don't have confidence in your skill. You have time, almost certainly. I feel very confident saying it this way. Normally, I don't like to say this because I don't know your context. But I think I know your context, and you almost certainly have time. You have excess capacity. And if you're not convinced by that, I encourage you to go get the book The Goal by Ellie Goldratt and read it. And it will convince you that you have excess capacity and that you will be able to do this. You might need to set a timer to avoid the situation where you start refactoring and then it's 2 days later and you forgot what happened. You might really need to start with 30 minutes at a time and then maybe an hour at a time before you find out really how much slack do you have. That's a way of measuring your slack. Almost everybody has enough slack. I have yet to walk into a company and fail to find excess capacity just lying around in the couch cushions. It's everywhere. And the important thing is to give yourself a chance to start so that over the period of some weeks or some months, your practice sessions will start paying for themselves. It'll never happen if you don't start. Now, what should I practice? Anything you want. Again, this is a useless answer. True, but useless. So let me say it this way. Practice anything that is demanding your conscious attention. When you notice that you have to slow down and focus hard to do something, that is something to practice. So that could be learning the IDE keystrokes or your editor keystrokes, learning some shell commands to do some automation. Committing changes to version control is a hilarious one for me, I have to say. Even after 25 years now, I still see programmers that when I ask them to commit, it takes them 5 minutes because they have to go and double check, no, I should add those files, but not those files. And I don't know if I should keep that change or that change. Look, man. And unfortunately, it is mostly men. Learn how to use the ignore file so that every time you want to commit to version control, it should just be add everything, commit. And if you're not there, fix it. Take the 30 minutes today and try to fix it. And if you don't get it done in 30 minutes, try 30 minutes tomorrow and fix it. So that every time you commit, it's just, I'll use Git as an example, Git add all, Git commit, type a message, done. If it takes you longer than 30 seconds to commit, there's something to fix. And again, I'm not blaming you. Everybody learns at their own pace. The problem is that many programmers don't understand the justification for making these kinds of improvements. That's part of what I'm here to tell you. When you feel resistance to commit, refactoring will be harder and slower. So learn it because it will make refactoring easier and less resistance. Do a small refactoring, commit the change. Do a small refactoring, commit the change. Do a small refactoring, commit the change. Anything that requires conscious attention is something to practice. And so these are just a bunch of examples. Choose anything. It doesn't matter. At the very beginning, you're just building up overall skill. As you start to have some of that chunking happening, then you will start to notice, here are my weaknesses, here are my strengths. These weaknesses are a problem for me more often. I will focus on those. But in the beginning, you don't even need to worry about it. Pick anything and practice it. The rewards of chunking are ease and confidence. This is what's in it for me. Programming is not difficult. I'm sorry, it isn't. And even design isn't difficult. We make it difficult for reasons I still don't understand. I want programming to be this kind of boring right here. That's the kind of boring I want. Pardon me just a moment. I want the hard parts of software development to be interesting, like talking with customers, figuring out what we should be trying to build, figuring out how to slice into smaller pieces, all that stuff. But when it comes time to figure out how to turn that into code, that should be boring and easy. And when you practice refactoring and evolutionary design, it becomes boring and easy. And I see there are at least a couple of people out there who push the question mark button. You're genuinely surprised that's possible. Well, follow my advice and you might discover it for yourself. I don't have to worry about how to design something if I can refactor in the right direction. I don't have to worry about, in fact, the real magic of evolutionary design isn't just that I can refactor my code. It's, if I feel confident in my skill to guide this design to evolve over time, then there's no such thing as getting the design right. My goal is simply to be less wrong than I was yesterday. Brian Merrick. Until you practice it, you won't experience it. People told me the same thing, and now I'm here to tell you. These are the real rewards. Programming becomes easy and boring, the right kind of boring, so that you can focus on the parts of your job that are actually difficult, like dealing with all these people. The power of rewards are amazing. When you do something that makes yourself feel good, your brain tries harder to remember how it worked. And that way your brain, because it's trying harder to remember how you got that reward, it makes it more likely that you'll get that reward in the future. That creates a positive feedback loop, and that's how refactoring becomes a habit. Refactoring becomes the way we write code. And when refactoring is the way we write code, I can start by typing return 12, even though that's stupid, confident in the knowledge that my next step will be 12 is really 2 times 6, and 2 came from there, and 6 came from that database table. And I don't have to build all that complicated code in one step. I can start by just doing return 12, and I'll figure out the details later. When refactoring becomes a habit, everything feels easier. And this, again, creates a positive feedback loop where you keep getting more and more rewards. And that's really what makes refactoring powerful. And that's why I encourage you to start. But where, you ask? Well, here are some suggestions. Now, refactoring workout in December 2021, obviously that's very out of date. Refactoring workout was an experiment that I ran trying to do some workshops where we did this kind of work. It didn't really work. I might try it again in the future. But certainly you can read more. The first blog is mostly about code and design. The second blog is mostly about these kinds of psychology questions. TDD.training is where you can see some real examples of how we learn to guide designs to evolve. And if you'd like me to do a refactoring workout with your company, I would certainly love to talk to you about how we would do that. Just go to jbrains.ca and let me know you're interested. And we can figure out how to do that for something as small as a 2-hour-long workshop. And they're much less expensive than you think they are. And now that we're all comfortable doing that stuff remotely, I don't have to worry about where you're located, and you don't have to worry about where I'm located. We just have to worry about the difference in time zones. I'm not a morning person. And that's it. So as a quick summary, what's holding you back from refactoring is probably more about your confidence and your skill than about having enough time. But you won't build refactoring confidence and skill if you never give yourself a chance to practice deliberately. Repetition leads to ease. Ease leads to chunking. Chunking helps you go faster, and it frees up space in your mind to think about bigger things. Like, should I do this refactoring now or later? Is this refactoring going to make the code better or worse? Are my teammates going to understand this code or not? But chunking then leads to confidence, and confidence leads to courage. I don't have to get the design right because there's no such thing as getting it right. There's only getting it a little bit more right than it was yesterday. A little bit more right than it was yesterday. I don't have to agonize over design decisions now. I trust myself to make the right decision at the right time, at the right moment. And if I make a mistake, it's not a huge problem to correct it. And that way, I don't have to worry about planning for the future. Now, I still want to plan for the future, but I don't have to worry about it. If I make a slightly bad guess about the future, it's okay. I'll be able to refactor in the right direction. I will figure it out when I get there. That is the real power. If you want to unlock the awesome power of refactoring, it starts with repetition, it goes through chunking, and it ends with courage. And when you have the courage to refactor anything at any time, magic happens. All right. And magic happened here because I actually have time to take questions. So,
all right, that's amazing. Thank you
let's
so
do
much,
that.
Prince.
You're welcome.
Yeah, as you wish. If you want, you can answer some questions, and also if you don't make it, you can answer them later. The rest.
Right. I will.
So
yeah.
maybe-
So go ahead.
Yeah. Do you want me to read them for you, or?
If there are a few questions that you think are particularly good to answer in front of the entire group, let's do those now. And then I'll go back through the chat and answer the ones that I didn't get to here today.
Okay, so I'll start from the bottom of the list upwards. So there is a question: how do I help my colleagues feel confident in their skill? Maybe that's something that you have lots of experience with.
Absolutely. And I think the number one, let me start by describing 2 reasons why they are not more confident in their skill. One is that people are blaming them when they make a mistake. So they feel like making a mistake is very expensive and very risky. So they choose never to do it. And the second one is that we believe that our bottleneck is time instead of skill, which means that we never make time to practice. And so the 2 biggest things that you can probably do to help your colleagues feel more confident, one of them is to shield them from blame, is to help them understand that they will not be punished for making a mistake, because making a mistake is part of learning. That's not just an aphorism, it's absolutely true. In fact, there's relatively recent neurological evidence or neuroscientific evidence that forgetting is an important part of learning. That by letting yourself forget things and then struggling to recall them actually makes the pathways in your mind stronger. So failing, forgetting, these are essential parts of learning. When you hire someone like me, you create an artificial learning environment where it's okay to fail. Now, you don't have to hire me to do that. You might be able to do that for yourself. Can you, calling all the programmers into a 1-hour practice session probably feels stupid and maybe it feels awkward, but you're creating an artificial learning environment where it's safe to make mistakes. And if you do it often enough, people will notice. They actually feel better about it. So that's one thing, is help people understand and feel comfortable and trust the idea that they will fail as part of learning. They will make mistakes. It will not go smoothly. And that's not just okay. That's normal. It's expected. It's required. And the second thing is help them find their slack. So this idea of starting with 30 minutes at the end of every task, it's a way to help people see the slack which is available to them. And maybe they have to start 15 minutes or 30 minutes at a time. And once they see that nobody is screaming at them for taking 30 minutes at the end of every task or 30 minutes every Friday afternoon, then they will try to take an hour. And if an hour is okay, then they will try to take 2 hours. And pretty soon they will find, how much slack do I really have? And then they can plan better. Those are really the two biggest things that you can do to help your colleagues feel more confident. Show them some trust and help them find their slack. Is there more?
Okay, well, I'm getting through them, and it feels like more that they are more sort of conversational things. I don't know if
right.
I
can read those later. So that's I'm definitely happy to continue the conversation for a little while after we stop here in the next few minutes.
Sure.
But yeah, is there another question in there that you'd like me to try to answer?
How to make team members to understand chunking and slowing down will help refactoring. When they want to do it, everything refactor at one stretch.
Yeah, this is one of the hardest things that what I observe when I pair with people is that in the process of performing one move, they notice something else. And then they go, oh shit, I need to do that now because I noticed it now. And therefore, if I do not do it now, I will forget it. And then in the middle of that, they'll say, oh, I noticed one more thing. Pretty soon now they are, shaving a yak and they don't know how they got there. And everything is mixed up together and they don't know how to commit it and they don't know how to describe what they did. And it feels very awkward. And then they say, oh, refactoring sucks. The problem in that situation is that this person didn't have a good system for managing their own distractions. So every time I'm in the middle of something, a thought will come to my mind or I will notice something else and I'll go, oh shit, I need to do that too. And in the past, that distraction would bother me. And either I would have to risk forgetting it or I would have to do it now, creating that problem I described. So there's a magic high-tech tool that you can use. It's called pen and paper. This is why I have a huge stack of index cards everywhere I work. Not just because I'm an old extreme programming guy, but because they're convenient for writing things down. It's no good to anyone in your head, Mozart. Write them down. So as you are doing something and you notice a distraction, write it down. I don't care if it's something which will take you 5 minutes or 5 days. Write it down. And the idea here is not to become a robot. The idea is, if you get these things out of your head and you trust that you will be able to look at your list later and not forget them, then you will stop wasting conscious energy on those things and you can focus on the current task and get it done. Now, I teach this, I call it inbox technique. It comes from getting things done. I don't know what David Allen calls it. He talks about getting stuff out of your head. What happens when you start becoming comfortable to get things out of your head like this is that it becomes easier for you to finish the current step before trying to start the next one. You no longer fall into this trap of, Let me do this. Oh, and one more step. Oh, and one more step. Oh, and one more step. And then suddenly everything is tangled together. It will be much easier for you to finish a step, commit, finish the next step, commit, finish the next step, commit. And in the beginning, this feels slower, but then repetition leads to ease, leads to chunking, and you will profit. So the answer to your question, how do I help them do it? What I do is I focus on something which is probably true for them, which is they feel distracted and the distractions hurt them. So I don't talk about chunking. I don't talk about repetition. I don't talk about finish this step before that step. We focus on this problem of feeling distracted. And I tell them, hey, try writing things down. Anything which takes more than 2 minutes of your time, write it down. You'll do it later. Maybe you'll do it next. Maybe you'll do it in 3 minutes, maybe in 2 hours, but you will do it later. And by writing it down, you can trust that you will not forget. And you don't have to waste your brain cells on remembering. And I help them build this habit. And by magic, indirectly, after they build this habit of writing things down and then crossing them off the list, it's very nice to say, ooh, there were 12 items on my list and I finished them all. I'm so productive. As a side effect of this strategy, they will find it easier. If I'm now doing a complicated refactoring with them and they try to switch directions in the middle of a move, I can say to them confidently, no, write that other move down. You'll do it later. Finish this move first. And they resist me much less. They are much more likely to do it because they understand the value. They have experienced for themselves the value of writing down their distractions and getting them out of their head. So you can start there. That's one thing that it doesn't always work, but it has the nice benefit of helping them solve a problem that they already admit that they are experiencing. Instead of trying to make them do something before they think it will work, you start with a problem which they are already experiencing, which they already agree is a problem. You give them a strategy for solving that problem. You give them a chance to try it. They start to like it. And then when you suggest to them, no, finish that part of the refactoring before doing that part, it's much easier for them to make the connection and say, that's right. This second refactoring, which I noticed, is a distraction. Let me finish the first move, and then I can do the second one. Just like I do when I have to remember to buy milk, or I have to remember to go to a meeting, or I have to remember to send back an email. So I would definitely encourage you to start there. One last thing I'll say is that as the person who is providing this advice, it feels very pleasant because it's like I have tricked them in a good way to learn something without taking them by the collar and shoving their nose in what they're learning. I'm just giving them a trick to solve a problem which they already experience. And as a pleasant side effect, they learn something else which will be helpful. And I get to feel like I guided them to learn something instead of teaching it to them, which if you read books on coaching and mentoring, apparently is a good thing to do, right? We want to help people solve their own problems instead of always pushing solutions at them.
Yeah, maybe the last one. I think you mostly covered most of the answer of this one, but partly comes before you actually agree that something has to be done. So how do you gently tell a colleague that their refactoring effort has actually made the code far more complex and difficult to follow?
Yes, there are two things that I want to say here. One of them is it's very important to make a distinction between this code is worse and I don't like what you did here. Many programmers waste a lot of time and energy arguing about good and bad when what they really mean is I like it or I don't like it. And sometimes the code is okay in that kind of design, even though you don't like it. You don't always get your way. So that's one part. But another part is we need to depersonalize the argument. Because unfortunately, most people, it's still true. If you attack my code, then you're attacking me, even if you're not trying to. It's natural, especially if I put a lot of effort and I feel good about the result, and then you tell me it's terrible, I will defend myself instead of listening to your feedback. And that's why we try a game that I call What's Not to Like About This Code. It's a game that I've published online at jbrains.ca. And it's a game that I play with clients where we gather programmers together and we look at code and we only talk about what we do not like about the code. We don't try to refactor it. We don't try to improve it. We just point out the parts that we don't like. And the question is very important. What don't you like about this code? Not what's bad, not what's better, not what's worse, blah, blah, blah. I don't want to try to make any kind of objective judgment. I want everyone to talk about a personal preference. I don't like that name. It's not precise enough. I don't like that method. I find it too long. I don't like this dependency. It makes it harder to test the client. And by focusing on I don't like, we deal with two problems at once. We allow people to talk about their preferences instead of arguing about what's objectively true. And we allow them to practice articulating the problem so that when they propose a solution and you say, we don't need to do that. If I can articulate the problem it's solving, you are more likely to pay attention to me. And it's more likely that we will agree on what are the problems, even if we disagree on the proposed solutions. And so this allows us to have some of these discussions about the changes in the design while removing the blame, removing the defensiveness, removing the personal feelings. We still have emotions involved, but it will be much easier for us to discuss if I don't feel like I need to defend my work. And that's why when we start to play what's not to like about this code, we start by talking about other people's code first. And then when the day comes that someone on the team volunteers their code to be the code that we talk about, you can interpret that as a good sign of increasing trust. So search the web for what's not to like about this code, and you can find some instructions there on how to play it on your own. If you need help, again, you can hire me and it's less expensive than you think.